The Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on acids. In our last lesson, we learned about neutral oxides and peroxides. We learned that neutral oxides do not react to acids or bases to form salts and water. We also learned that the oxidation state of oxygen in peroxide molecule differs from that of other oxides. In today's lesson, we will learn various definitions for acids. We will learn the Arrhenius definition, the Bronsted-Lowry definition, as well as the Lewis definition. Acids are some of the most familiar chemical compounds. When you think of acids, you might think of acetic acid in vinegar or citric acid in citrus fruits, such as lemons. Phosphoric acid provides the flavor for many carbonated beverages, and hydrochloric acid is found in our gastric juice. It is an essential part of the digestive process in our bodies. But what is an acid? Savant Arrhenius, a Swedish chemist, offered one of the simplest definitions. He defined an acid as a substance that releases hydrogen ions or protons or hydronium ions in an aqueous solution. For instance, hydrochloric acid on its own releases hydrogen plus and chloride ion. When reacted with water, hydrochloric acid releases hydronium and chloride ion. In order for a substance to be called an Arrhenius acid, it should contain ionizable hydrogen. Some examples include hydrochloric acid, nitric acid, sulfuric acid, hydroiodic acid, hydrobromic acid, and hydrofluoric acid. Despite the fact that Arrhenius' definition was simple and useful, it does have some limitations. His definition only addressed the behavior of acids in aqueous solutions. Also, his definition fails to explain why some substances display acidic behavior in the gaseous state as well as in non-aqueous solutions. The union of ammonia and hydrogen chloride gas offers an example. When they are brought together, ammonium chloride is formed, as in this chemical equation. The hydrogen chloride provides hydrogen ion H+, which reacts with ammonia to form ammonium plus. However, this happens in the gaseous state and not in aqueous solution. Therefore, chemists tried to define acids in a more general way. In 1923, Johann Bronsted and Thomas M. Lowry each individually produced the same new definition for acids. According to this definition, an acid is a substance that donates protons to some other substance. If we look at these reactions, hydrochloric acid, water, and phosphoric acid are Bronsted-Lowry acids because they are proton donors. Students, this is a good time to point out that while all Arrhenius acids are Bronsted-Lowry acids, the reverse is not true because Bronsted-Lowry acids include substances that are not acids according to Arrhenius. Even though the Bronsted-Lowry definition is broader than that of Arrhenius, it still relies on the transfer of protons. Since there are acids that are not proton donors, chemists began to look for another definition for acids. Students, before we discuss the Lewis definition for acids, let us do an activity. In a moment, you will see several sentences that are related to the Arrhenius and the Bronsted-Lowry definition of acids. However, some of the words will be missing. Please fill in the correct word to complete the sentences.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. I am sure you had no trouble filling in the blank sentences. Let us discuss them together. The simplest definition of acids was suggested by savant Arrhenius. Some examples of Arrhenius acids are hydrochloric acid, nitric acid, and sulfuric acid. You might also have mentioned hydroiodic acid, hydrobromic acid, or hydrofluoric acid. A broader definition of acids was created in 1923 by Johann Bronsted and Thomas M. Lowry. The Bronsted-Lowry definition of acids is that an acid is a substance that donates protons to some other substance. Gilbert Newton Lewis, an American chemist, came up with another definition for acids in 1923. It further extended the Bronsted-Lowry definition. According to Lewis, an acid is a substance that can form a coordinate covalent bond by accepting an electron pair from another substance. Thus, acids are electron pair acceptors. This reaction between boron trifluoride and fluoride ion acts as a Lewis acid because it accepts a pair of electrons from fluoride ion. Students, let us do an activity. Please explain how the Lewis definition of an acid is valid for the Arrhenius and the Bronsted-Lowry concept. You may begin.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I hope that you did not find this activity to be too difficult. Let us review the answers. The Lewis definition is valid for the Arrhenius concept because as the acid releases a hydrogen ion in aqueous solution, the released proton accepts a pair of electrons from a water molecule to form an hydronium ion. The Lewis definition is also valid for the Bronsted-Lowry concept because Bronsted-Lowry defined an acid as a proton donor. The donated proton can be accepted by a molecule that has a single pair of electrons. Thus, the proton is an electron pair acceptor and therefore a Lewis acid. In this reaction, we can see that water is a proton donor and thus a Bronsted-Lowry acid. The proton that is donated from water to ammonia accepts a pair of electrons from the nitrogen atom in ammonia to form ammonium ion. The Lewis concept of acids includes hydrogen plus as an acid. It also includes ions or molecules that are able to accept an electron pair that neither release hydrogen plus in aqueous solution nor donate a proton. Today, we learned about several definitions of acid. We learned about the Arrhenius definition, the Bronsted-Lowry definition, as well as the Lewis definition. This is all for our lesson today. Until next time, thank you, teacher. Thank you, students.